Hello and welcome to Careerera. Today we will be continuing the tutorial of data science tutorials, and the video number is 2.3, and we will be covering linear regression. We already discussed one video of linear regression where we discuss how to implement this. We created a dummy data set and we worked on it. Now today we will be importing a data set from sklearn only. It will be a diabetic data set which has the value. Now, because I want to make it a little simpler initially, we are not going to use pandas anywhere, initial point. That is, we are not going to do the wrangling part, the data cleaning part, which is also a very important part in machine learning or data science project. But we are getting a data set which is already in numerical form. So all the columns and its values are in numerical form. Again, it is not human friendly, but it will make a lot of sense when you read it. Okay. So we will be implementing this data set. We will be using this data set and to find the target value. We will have a X and Y is my target value. X will be my independent columns. And I'm going to give this to my data model. I will import linear regression. And then once my model is fitted and trained, I will check the accuracy. Okay. Now, once I'm done with all the processing and checking the, how the model is performing and all those things, I will also try to plot it accordingly. Now, plotting is not a step you can say which we use every time when we are doing the work, but plotting can be an easy thing to understand for, especially for human eye. We don't really plot every time, so plotting is just one or two demo thing. We will be not doing it again and again. We will focus more on the performance and hyper tuning part rather than just plotting. So concluding all this, let's move towards the code and let's start with it. So let's continue with the project, and we are going to import the important libraries first. So first of all, this project is diabetic dataset. So let me take this link from here so to save my time. It's diabetic dataset project, and we will be using linear regression here. And let's make it capital. Let's put some size increment operator, and this is here. So we have this diabetic dataset project, and we are going to use linear regression here. And we will be using matplotlib too, so that is why I'm putting it. Again, it was imported below. I just cut it and pasted here just to make it show, it is visible in the top. Usually, you can always pick all the import libraries in a single cell. So once you're done with the project, I simply cut it and paste it here. That is all. So and we all have all the import libraries in the same cell, and it saves a lot of time. Mean square error is not something that I'm going to use, I believe, and uh, R2 square is what we are going to prefer, because mean square error usually give you just the total number of error that we have. It very rarely makes sense, to be very frank, MSC, because you're not going to calculate how many data points are there, so how much error is giving, so on average how much error we have for each and every element. This is not practical to do, and it will not make sense to most of the people. R2 square on the other side give you a decent score and give you the clarity. Okay, this is the score. So it starts from 0 to 100, and more towards it is 100. That means better your project is. The values usually come from 0 to 0.9592, something like that. That means 98% of the value is towards the 100. That is one, you can see on normal terms, 0 to 1, and more towards it is going towards 1. Better the model is performing. So R2 square, adjusted square, all these methods are basically used to check the performance of your model. And this is all later. Let's start with the project first rather than talking. And we import the library. So we import matplotlib, we import numpy. We are going to use numpy in few steps. That is why I'm putting it. Once you're done with this, as you can see, I'm not importing pandas anywhere because I'm not going to use pandas. The reason for that is when you print diabetes, you will see that they are all numerical values. You don't require pandas at that moment. Once you're done with that, from sklearn import dataset and linear model. Okay, then sklearn metric, import mean square error and R square score. Now this particular values are this particular libraries are going to be used to check the performance of the model, which is the very last step. This is the main step. You will use dataset and you will use leading model. Once you're done with this, again, guys, this is a one way of doing it. You can divide this into two lines. That is, you can use sklearn dot linear model, uh, import. So from sklearn dot linear model, import linear regression, and that is also a practical way of doing it. But you can save your time like this too. Whatever way, whichever way you want to do, it is on you. Once you're done with this, you can simply move forward. So let me run this cell. Okay. Once you're done with this, we can simply move forward. And I'm just loading the data set. So loading diabetic, and I'm saying X and Y has to be true. That means we will get an X and Y separately. We are catching the values X and Y and two variables. So it is giving us two variable value. We're catching it in two variables. And once we're done with loading, we will print diabetic X. I'm using transform here. Transpose is basically used to make rows into column and column to rows. The reason for that is that we are having column in the rows and rows in the column. So it is hard to understand that way. That is why I'm using transpose to make it easy to understand. So this is the kind of value that we are having, and these are the values. Once you have this value, let me remove transpose for the moment, so it makes clarity. Okay, so these are the values, and once you're done with this, and we have y2, so I'm printing y2. These are my y values. Okay, so we have x and we have y. A lot of values are there, of course, and we can simply find the shape and we can check how the values are, how it's really working. So once you're done with this, you can add one more step. Okay. This is my shape, and let's check diabetic y shape too. Let me paste it. Let me copy it completely and paste it. Make it y. And, all right. So we have this shape. So 10 columns are there. 442 rows are there. And diabetic y. This is basically this is our target. This is my target value. Okay. This is my target value, and I'm getting 442 in my target value. Now it is in our hand how many features we want to use. In case you want to drop a feature, you want to use a feature, you can drop and use it. Again, it is completely your call what you want to do. I am going to use all the features rather than dropping any. I don't want to drop. I don't really see any sense in dropping any column. And just moving forward, what I'm doing, I'm splitting the data into train and test split. And what I'm doing here, rather than using train and test split, I'm doing it in this way. Again, this is you can say normal way, but I strongly recommend that you go for from sklearn. Okay, and from model selection, just import your split, and it will make a lot of sense. It will make your life easy, and it saves a lot of time too. Here, test, and you can simply import and do this. Moving forward, once you're done with this, you can split it in this ratio. So you can copy the steps, so you can use your own trend split, whatever way you want to do. You will be making the value 0.2 in case of trend split. Once you're done with the splitting part, what you will do, you will simply move forward, and as you can see, I'm making X train and X test, and then Y train and Y test, and X train has the output of Y train, and X test has the output of Y test. If we check the size, it Y test and Y X test will be equals to 20% of the value, and this is what we are getting. So let's move forward. 1 second. All right, so let's move forward. So let's run this cell. Okay, and move on. Now I can remove this too. I can use it too. It's on me. Again, if I use it, say train test underscore split, run it. I will just need to use it in the next cell. I hope you already know this drill, that you just use it. You will keep these variables. Okay, X train and X test, then Y train and Y test, and once you're done with X train and the Y train, comma X test and Y test, and once you're done with the drill, you move forward and put it the split size X, the test size will be 20%, and random can be anything, and you can control like that. Right now, this I'm not using it, so I'm not going to keep the cell like this. I will make it a comment to avoid the confusion here. We are splitting it in this fashion, so that is what you need to mind. Once you're done with splitting, if you check the shape of all the diabetic, all those things, so diabetic X, diabetic YX, test everything. So if I check the shape here, this is my shape. Let me let me copy this, paste it again, paste it again, paste it again, and make it white train, make it X, test, X will be capital, and make it a Y test. Once I'm done with this, I have this shape. So you get the idea. I hope it is clear. We are getting this X train. So X train is this. X test is this. Okay, and we have dependent column of 422 and of 20. Size is same. Same is good. And if the size is correct, there will be no issue. I hope there will be no issue. And running this, I'm just importing a linear regression and dot linear regression. Guys, once you're done with this, you will be creating object for this. That is why I'm creating reg x regar. You can also call it lr, whichever name you want to use. So even if you call it lr, that is okay. That is what usually we use as a name. So LR is what linear regression stands for, and LR model is there. Of course, if I'm changing the name, I have to change it and every cell. That is one thing I need to mind from now on. LR, once I'm done changing the name, I will be fitting it. Okay, so LR dot fit diabetes X train, diabetes X Y train, and I will be fitting it. Once I'm done fitting it, as you can see, I'm getting an output. That means the fitting part is done, and the name will be LR here again, and dot predict, and I will be predicting the value of diabetes. And once I'm done this cell, let me print the predict value. This is my predict value that I'm getting, and this is what I'm getting as an output, and this will be LR2, making it LR. Okay, so these are my coefficients that has been there. So after predicting, coefficient is the value that get multiplied in the equation, and whatever the coefficient you're having, that value is getting printed. That is this is usually not required. You can, when you want to get the insight in how the network is really resolving everything and solving everything, that is where you use this kind of value. Frequently, we don't really go for coefficient. We require just to put the values. So, if we talk about the actual projects, we check the null values, we check the categorical values. Once we are done with that, we start modeling. Once we're done with the modeling part, we move forward and check the accuracy and stuff like that. So, straightforward, coefficient never really comes into the picture in that moment. Moving forward, what I'm printing the, let me make it format so it is easier to understand. Okay, let me make it like this and put it like this. Let me delete it. Dot format, putting a bracket here. Our bracket is sufficient. 1, 2, open, 3, open. 1, 2, and we need to third to close it. If you run this, you get this mean square value, and this is my value. So I get an idea. Okay, this is my mean square error, and this is what I'm getting from X test and predict. The value usually goes down after training. That is what we are expecting. In the second cell, I'm just printing using the format again. I'm using R square, and I'm passing uh, diabetic Y test and diabetic Y predict. Once I pass this, I'm printing the value. Uh, Printing the value for score part. So once the score is printed and the mean square value is printed, I will move forward. And last cell that I'm going to run again, guys, we are getting r square value as 58, which is not very you can say decent score, but you can say it's okay score. 50 around score is not very decent. I usually expect at least 75 score when I'm going decent, and when you're going good, you can expect even better score. But right now, as you've not done it in very careful manner and we have not already worried about the values and stuff, we are getting a little low score, which is okay at the moment. We can live with this, no issue. Moving forward, we need to plot. Now to plot, we already have the import of matplotlib above. We will use the same library. So matplotlib is plotted is imported as plt. In the plt, you can see I'm first line, I'm using scatter plot. I'm giving diabetic axe test. Now guys, plotting is just for us, not required. You can literally add the project above in the above cell where you have printed the coefficient. You don't really need to plot it. Okay, that is one thing. Now scatter plot diabetic axe test, diabetic y test, and color is black. For the second plot, I'm using a line. So I'm using a plt dot plot, and giving x test, and I'm giving y predict. Notice I'm changing the value of y predict here. Okay, so it is not y test, it is y predict this time. Now it will be creating a line which takes the value from prediction. So what kind of prediction the model has made for the coming output. Once you're done with these two steps, you will just print it. Okay, and obviously x by level will be used where you have to put the name. We are not using anywhere, so it is, you can say, a removal step. It's okay, and we get the output like that. So let me also remove this, it is not required. And if I run this, okay, it is saying some error. Let me check the error. X must y has be the same, should have the same. Size is not same, it is what it is saying. And let me check, did I miss the name somewhere? LR. Okay, LR coefficient, negative extreme matrix. Okay, then in that case, this it should not be giving this error. Not really sure why. So why must be of the same size? So let me check the error resolution. 1 second. So I'm giving the correct value. I'm not doubting the correct values. I have to give one correct and one this. Not required this value anyway. It is giving me the error in which line. Let me check that too. And it is giving me the error in scatter plot part, and where it is saying x is y test, and we giving this. First line, that means the model has some issue. If I'm also same size, now it is saying it is not in the same size. Let me check the size first. So if I'm giving the value of x test and diabetic y test, okay, both should be of same size. So x test and y test is missing. Let me print the value, then it will save my time rather than finding it like this. Let's print the value. So what I'm doing, I'm just going to print these two values. I'm just taking print, giving the variable, and let me give some space in between, so at least I know that I have given some value, and not much helpful. So let me you know dot shape dot shape. Okay, so it's 210 and 20, and so scatter plot is taking a decent value. I don't think there is any issue with the value. It is okay. And diabetes X is also correct. I don't think there is any value with the plot value. Let me rerun the cells. I think some issue is there. So let me rerun the cells. So let me refresh, start. Okay, all variables are lost now. And let me take it from the top. kernel. You start with an all cell. Yes, let us do that. Getting the same error. So there is some issue, definitely. X and Y must have the same size, which is not there. So X and Y. This is my X and Y having the shape. Number of rows are equal, and that is what we need to check. And I don't see any issue. I must have substituted the value somewhere. Let me check. So let me also print these two values. Maybe mistake is there. Let me check these two sheets too. So one is test only, and I always want to check the print part. So print, and here's the shape is okay. So this should not be having an issue. The same size is correct. So getting back to the code, guys, what I was missing there. So I took a pause and just checked the code. So I was missing this none part. So the main thing is that for plotting, if we are just going for linear regression, it was okay. But for plotting, we need one axis. I forget to notice this second axis. Okay, 20 comma 1 should be there, and only when you have this you will be able to plot it. So if you just remove it and run it, you will get the plot. Okay, that's the only thing that was missing. Apart from that, everything was okay. So I hope you get the idea, with the plotting. So one thing that we missed at the moment, that we have to keep it one axis. We cannot give multiple axis in a single pot, or that is obviously with that we have giving we're giving x and y axis. Basically, you cannot give multiple uh, points for y axis. That is never acceptable. Okay, and you cannot do the same thing for y x-axis too. So if you're giving multiple points for x-axis, it is hard to plot for any plotting, right? It is not practical. That is why we are having that issue. So I hope it is resolved and is clear. Apart from that, everything is okay. So guys, I hope you get the idea, and this is the plot that we are getting, and this is all for the code. So we will be discussing further what regression can do for us and what we can do with the coding. Let's take 1 second, just get the run part done. Once you're done with this run part and this plotting part, you can move further. You can pause and you can do this plotting first and do all the coding first, then we can move forward. So I hope you get the idea. So as we have discussed up to this point, the regression work in this fashion. Okay, so I hope you get the idea that we are plotting the lines. Basically, we are plotting the data set, and we create a best fit line in between. Okay, so just repeating what we have done up to this point, we have collected a data set, we fit our model. Fitting means this only, we are plotting the points. Basically, you can say, think about it like this. We are giving this data set to our model and it fits in. Once the fitting is done, this best fit line is find out. Now we will talk about the procedure, what is going on at the back end. We understood the mathematics, we understood the coding part. So how to code, how to implement regression, we are clear up to this point. Okay, now we will discuss that how the things really goes on. Okay, so let me put it here. Let me, 1 second. All right, so let's discuss about the point. So I'm taking any random one point. So this is my point. Okay, this is my point which I'm focusing on. This is the point there which I'm going to discuss. We will plot this point, we will discuss, we will calculate the distance of this point from the line that we have plotted. Now this is my line. Okay, now first question that should be asked is, that where this line is coming from and where it is going to start. It should not be think like this, that is starting from this point. No, you see this x-axis, lines start parallel to this. Okay, so line is exactly parallel to this particular line. Line starts parallel. Okay, I'm just drawing a rough line here, and this line keep moving. Okay, this line start moving towards. Now question number two, how it starts moving. So the angle that it has, okay, this angle keeps changing, and this angle is considered best with m. Okay, the convergence that we discuss is in this angle. Okay, now this angle is changing, this line is moving, and this line keeps moving forward. It keeps moving in a fashion that the loss, now what is loss? The error, the residue, that means the distance of each and every point. So we will calculate distance of each and every point in this line, from this line. Okay, and calculate the distance. Now at this point the line is here, so we will be calculating the distance from this line. Okay, sorry, the line goes a little up, it is up to this point only. So we calculate the distance from this line. Okay, and from this line how much away it is, how much away, how much distance there is, and this line keeps moving forward towards down. Okay, and so on till it reaches to a location where the addition, the residue. Now guys, what is the residue? We add the distance, complete distance, and we call it loss. Okay, what is loss, residue, all the same thing. So we calculate this residue, and this residue is basically getting down. It is getting smaller and smaller. Initially when you start with the starting position, this value is very high. Okay, this value is extremely high. It start dropping as the line start moving, as we change the value of m. Okay, it start moving down, and it keeps dropping until we reach to a location which is called global minima, which is called global minima. And now let me move this. It should be, one second. All right. So until it reaches to the global minima. So global minima is basically nothing. It's just a location at the center. So this line is moving. As it keep moving, it creates this location, this curve, this parabolic curve. This curve has a global minima point. Now this global minima means the error keep reducing till you reach this point. Okay, it keep reducing till you reach this point, and the moment the error is minimum, okay, the moment error is minimum becomes your global minima. How you find this point? The moment you cross it, the error start increasing again. The error start increasing again. So you come one step back, okay, and declare this point as global minima. This point becomes your global minima. This is called global minima, and this is called gradient descent. And we have already discussed how to find out and how to be reached to the gradient descent part. So this is how the work is going on at the back end. So we have seen the implementation and the coding, and this is how it is solving it at the back end. Once it reaches the global minima, it declares the Basset line, and this is the result that we find out after fitting. And then what we do, we go for prediction. Now let's talk about a little about prediction. What really happens in the prediction part? Let me clean all this and let me draw a line in front of it. Let me draw two lines basically. So suppose this was our data set of train. Okay, this is my training part, this was my training part, and this is my test part. Okay, test part, validation part, whatever you want to call it at the moment, it's okay. Test or validation doesn't matter. Okay, we will test our model from this. So we will give these point to the model and see if we extend this best fit line. The moment we extend the best fit line, we will calculate the distance. This error should be very less. If it is very less, it is performing good. Then we check how much score we have. The R2 score basically gave us how much good your model is performing when you check the residue of the test part. Now, if the model is performing good, the score will be from 0 to 100, or we can say 1. It can be point, say 0.95 or something like that. And if it is 0.95,
That means your model is performing really good. Okay. Now we move forward, and in future, suppose how the prediction part done. So actual testing. So suppose this was validation. This was validation. So when you go for the actual testing, it predicts the future points will be coming here and here. Okay, it predicts like that, and that is how the prediction is happening in linear regression. Okay, this is the way model is getting trained, model is getting testing, and we do the main testing part. So main testing which we do in the training part is called validation. So we divide data set into three parts: train, test, and validation. And this is how the process goes on. So let me clean this. I hope the logic is clear on this. Moving further, so we talk about residue now, residue and total error. Now when we talk about residue, we are calculating this distance from each every point. So that is why I have taken a very small number of dots, so it is easy to explain. Okay, every distance is calculated, and as if you just if you think logically, the initial distance will be very high. Initial distance will be very high, and as the line moves toward closer to this, the error will go down, the residue will go down. That is quite obvious. And the moment it crosses the best fit position, okay, these points will get closer. These points definitely get closer, but other points will get away. Okay, these points get start getting away, and that is why the error increase. Okay, so line can be best fitted from any angle. It is not just one particular angle, it can be from any angle. And this am value is changed by the convergence theory. We already discussed the mathematics for this, that the am will be subtracted from old am. So old am, so I'm saying old am, and this is my new am, and it will be subtracted from the learning rate. Okay, and derivative of loss, that is the error that you're getting, divided by derivative of am. Okay, and old am, that is. And once you get the value and you subtract this value from this old am, you get the new am, and this new am is implemented every single time, and we keep finding a new am, and we keep finding the this new value, and keep moving forward. The line keeps moving, and we get the best fit line location. So I hope it makes sense how residue really works and how the work is going on. Moving forward, same scenario that we will discuss again. Now we will discuss these 2 points in depth. Okay, we did it in quite fast fashion that time. So what is the issue with lambda? Learning rate is small, learning rate is big. Why we are considering this? Because the issue that we face is that usually happens that when we are moving, as we discussed, guys. I hope you understand why global minimum point is important. Okay, because this gave us the best fit line location. This is the best fit line location. It is the most important area where we want to reach. Now to reach this value, reach this point, we do fit. Okay, we do this fit part. And when we do this fit part, it start moving, the line start moving, the line is like this and start moving in the down direction. Now am value is changing every iteration. The am new value will be happening, so this formula will be processing, and we give a new value for am. This line keep moving, and it keep moving. Okay, now think about it. If it is taking a very small step, say baby steps, okay, and the lambda value is very small, say 0.00000001. Okay, now we have around 5 to 6 zeros and then 1. That means the value that we are going to multiply with it will be very small too, and that means the new am value will not be very away from the old m value. That means the lambda value is small and the steps are small, and it will reach global minimum. Definitely it will reach global minimum someday, but it will take it forever to reach here. It will take a lot of time. Extreme amount of time is required to reach global minima with this step. I give you an example, guys. Suppose you want to reach to a market. Okay, this market is 10 kilometers away from you. Okay, and you decide to just go by walking, taking baby steps. Okay, so this is a market, this is a market location, and you are standing here, you are standing somewhere here. Okay, this is you, and you are standing somewhere here, and you want to go in this direction. You will start walking. If you start walking in baby steps, that means half foot just away, and you keep taking baby step, and You know, guys, again, if you're taking baby steps, it might take a very long time, but you will reach market. That is a for sure thing. Okay, so you know, even if you're taking baby step, you will reach there, but again, guys, it might take you 3 days. Okay, just cover 10 kilometers area, it might take you 3 days. Okay, now that is a lot of time that you don't want to give. You definitely don't want to give 3 days just to reach a market or a small bit. Suppose you just want to eat something, something small is there, so you don't want to waste that kind of time. So how can you improve that? So guys, suppose second scenario, suppose I want to increase my speed and I decide to take a plane for that. Okay, I decide to take an airplane to reach there. Now taking an airplane can be might sound a very good idea at the moment, but it is not. Suppose you are taking a plane, it will take you with a very high speed, extremely high speed. Okay, so if it is just 10 kilometer away, it is was just 10 kilometer away. Okay, plane will just take off and take come down until, again, 10 kilometers is a runway path, so it will just take off and come down, and it will definitely cross the market. It will never reach the market. Again, if you are away, you're far away from the market. So what you will do at this moment? Okay, you want to go market really badly, so you badly want to reach market. What you will do, you come back, you again take the plane and come back to location. Suppose you, it is now 8 kilometer away, you come back to a location where it is just 8 kilometer away. Again, you will take off, go again, and you will reach somewhere away from the market, say 5 kilometer away. Now you can again take, come back and try to get closure, so you will reach, say, 7 kilometer. Now again you will go back again. I hope you get the idea. You keep jumping, guys, you will keep jumping forever, but you will never reach market. You might never reach market. So taking a plane is not a good idea. Walking with baby steps not a good idea. So what is the conclusion? What you can really do in such scenario? The best way that has been presented is, you take something which is not too slow, not too fast, say a car. Okay, car can be a very good option to reach this market. Okay, it will save your time, you will reach there on time with good speed, and it will save you a lot of time for you. Okay, so I'm using a car to reach to the market. Now I will reach market for sure with a decent speed. But again, guys, there is another concept that has been introduced, that is this concept. Now how linear regression really works is, it does not really go very fast or doesn't go with the constant speed. Okay, because we want to save some time, so most optimal way of doing it is, rather than reaching market, so again you might not get the parking. So what you can do, and you might have to park it somewhere else, maybe a little away from the market. Okay, and then you have to walk. So to save your time, what you can do, you can reach to, say, a 9.5 kilometer from car. Okay, and remaining 0.5 kilometer can be covered by walking. This will ensure that you will reach to the market in the most optimal way. Okay, so you will drive till 9.5 kilometer, then you will park the car, then you start walking. Even if you're taking baby step, you will reach there in time. Okay, that saves time. It is the most optimal way, and you will never miss global minima. Missing global minima is not a practical way of this. So this is what it is happening. It is taking leap steps initially, then taking the minimum step and reaching the global minima at the end. I hope this example makes sense to you. This is what linear regression is doing at the back end. I hope it is more clear and it makes far more sense now. Why not to keep lambda very small? Why not to keep lambda very high? It is alpha at the moment. Usually we define learning rate with lambda. Lambda and alpha both are pointing to same condition, that is learning rate, same element basically. So guys, we are having this learning rate very small or large, it will make an issue. We don't want that, so we avoid it. Okay, that is how gradient descent linear regression works together. Let me clean this and let's move forward. So we will be discussing in the coming time about logistic regression. It belongs to the regression family only. So a little bit introduction is required. Just I'm introducing this. I will cover it properly in the next class, where again we will be doing a little bit of practical, where we will be doing a little bit of theoretical, and we enhance our knowledge. So in logistic regression, We have regression because it belongs to a regression family. It uses the S curve, and it is a binary classification. The reason it is called a binary classification is because it decides between two classes, 0 or 1. We will discuss this in deeper, why this two classes and why this and that. Again, there are several extension in linear regression and logical regression too, which is, you can see, a little advanced machine learning, which we will discuss. Once we are done with regression and logical regression and linear regression, we come back and we'll discuss those methods too. Okay. So in linear regression, you have this, you can say L1 and L2, which is a regularization technique. Now we have to understand what is regularization technique and why to even use it in the first place, and what is the use of it. Okay, we'll discuss that clearly. And regulation technique is very important, especially in deep learning part, where we will discuss other dropped out and other topics. Let's not talk about that at the moment. Coming back to the topic, sigmoid function formula is 1 by 1 plus e to the power minus z. And this function takes the value from 0 to 1. So you have 0 or you have 1. Okay. And it is decided by the p-value. So zero point 0.5 is the, you can say, um, threshold. Above this is 1, above, below it or at the same level it is 0. So this is how loss regression really works. This is all for loss regression and regression part. In the coming video we will discuss logistic regression and their implementation. And once we are done with this, we will again come back and discuss even in depth what we can do, what regression, what we have in the regression. So this is all from my side today. Thank you guys. Thank you for your time. This is all.